Hi, this is Involved Innovation YouTube channel. In this video, we will see about how to record the audio and save it in the SD card. We will design the screen to start and stop the recording and increase and decrease gain. In the last two videos, we have saw about how to set up the development environment, which is a prerequisite for this video, and in another video we saw how to turn on and turn off the bulb with a UI screen button. For this project, we need SD card with 16 GB or less in size is preferred. This need to be formatted with FAT32 format. First, we will format the SD card. Make sure the SD card does not have any files in it, and insert the SD card in the card reader and plug it into the system. Here it is in the E drive. Right click the drive and select format. Select FAT32 in the file system and click start. Now the format is complete. I will remove the SD card and then insert this SD card in the CrowPanel Advanced. Now open the Squireline Studio. Click Create Project. Select Arduino and choose Arduino with TFT ESPI. Name this project as audiorecorder.spj. Make sure the resolution is aligning with your display. In my case, I am using CrowPanel 2.8 inches, so I am selecting 320 and 240 pixels. And select the color depth as 16-bit instead of 32-bit. And click Create. First, we need to add the asset record for this project. Click Add File into Assets button. Select Microphone and Stop Red PNG files. You can find these assets in my GitHub repo, the link of which I have provided in the description. And click Open. Drag and drop the image widget to the screen. Place it on top center and then select the microphone image from the asset drop down. Change the scale of this image. I am scaling this to 150. Still looks big. Scaling it down to 60. Still looks little bit big. Scale it down to 30. 30 looks fine. And add button widget here. Resize the button to look square. Change the background of the button to white. Now drag the image on top of the button in the hierarchy pane. Now the button and the image will be acting as a single component. Add one more button to the screen for increasing the gain and reduce the size. Change the background to green. Click label widget and change the label text to plus. Increase the label font size to 34. Position the label inside the button. And change the font color of the label to white instead of black. Now move this label inside the button. Drag and drop the label on top of the button in the hierarchy pane. This is to make sure the label and the button acts as a single component. Right click the button in the hierarchy pane to duplicate this button. Drag the duplicate button to the right. Change the label text from plus to minus. This button is used to decrease the gain. Change the color of the button to red. Click button widget. Resize the button to make it square and change the background to white. Add an image widget to the screen. Select stop underscore red in the asset drop down. Change the image scale to 30. Position the image inside the button. Now drag and drop the stop red image on top of the button in the hierarchy pane. Position the stop image inside the button widget. Now select the button one in the hierarchy pane. Go to the events pane and click add event button. Change the trigger to released. Select the action as call function from the drop down and click add. Name the function as start recording. We will add logic to this function in the UI events file when we are coding it. Likewise, select the button tool and navigate to the events pane and click add event. Change the trigger to released and select the action as call function and click add. Name the function as increase gain. Similarly, select the button 3 and navigate to the events pane and click add event. Change the trigger to released and select the action as call function and click add. Name the function as decrease gain. Finally, select the button 4 and navigate to the events pane and click add event. Change the trigger to released and select the action as call function and click add. Name the function as stop recording. Click the play button and click all the button to check if there are any errors. I can see no errors, so we can start exporting. Go to the file and project settings, set the project export root folder by clicking the browse button and select the folder and set the UI files. Export path by creating the output folder inside the root folder and click select folder, and now click apply changes. Select export and click export UI files. Now all the file is exported to the output folder. Now open the Arduino IDE and create a new sketch and save the sketch. I will name this as audio recorder, and go to the path where you have downloaded or cloned the GitHub repo. Copy the contents of the squireline base folder. Navigate to the path where the sketches are saved. Go inside the audio recorder folder, paste the copied squireline base folder contents here. Delete the audio recorder.ino file and rename the 2_8 lvgl.ino file to audio_recorder.ino. Now go to the folder where we have exported the squireline UI files. Copy all the files and paste it in the audio recorder sketch folder. Here change the UI events.c file to UI events.cpp file. We need to write custom logic to support the SD card and use microphone, so we are converting it to C++ file. Go to the Arduino IDE and open the UI events.cpp file. Navigate to the folder where you have cloned or downloaded the GitHub repository. Go to the audio recorder folder. Inside this folder, copy the contents of the UI_events.cpp from here and paste it in the opened UI events.cpp in the Arduino IDE. Here this class has start recording, increase gain, decrease gain, and stop recording functions. Start recording starts the recording and flushes the content to the SD card and also logs the message in the serial monitor. Increase and decrease gain to change the recording volume. Stop recording function to stop the function. Add the helper functions such as audio recorder init, which returns boolean, and audio recorder process and is recording, which returns boolean, and get gain, which returns int in the UI events.h file. These functions are already implemented in the UI_events.cpp, which we have already copied and pasted. Now open the INO file, add the lines to print the initializing audio recorder in the serial monitor log, and call the audio recorder init in the setup function in the audio recorder.ino file. In the loop function, call audio recorder process function below the lv_timer.handler function call. Now we have done with all the code and setup. Compile the code. Once the compilation is successful, connect the USB-C to the UARTC port. Make sure the SD card is inserted in the CrowPanel Advanced. Now click the upload button. Now the code is uploaded successfully to the CrowPanel Advanced. We can able to screen which we have designed in the Squireline Studio. To start the recording, click the record button in the screen. In the serial monitor, we can able to see the recording started and we can able to see the log for every 1 second. We can stop recording. Now the recording is saved to the SD card. Insert the SD card to the card reader and plug it to the system. We can able to see one recording wave file. I hope you have learned a lot in this video. We have seen how to design UI in this Squireline Studio and how to use the inbuilt microphone and how to save the recording in the SD card. Thanks for watching. If you have liked this content, share it with your friends and subscribe to this channel for more similar content.